70 people died because of a piece of tape. On October 2, 1996, a Boeing 757 lifted off from Lima, Peru, into the darkness over the Pacific. Its engines ran perfectly. Nothing was bent, broken, or on fire. And yet within minutes, the crew had no idea how high they were or how fast they were flying. Their altimeters and airspeed indicators fed them numbers that made no sense and kept changing. That aircraft was Aeroperú Flight 603. What doomed it was invisible from the cockpit and sitting 15 feet up on the side of the fuselage. 3 small openings called static ports, sealed over with masking tape that a mechanic had forgotten to remove. To understand how tape brings down a jet, start with how an airplane knows its own altitude and speed. An airplane never measures them directly. It infers both from air pressure. Along the side of the fuselage sit flush metal plates with tiny holes in them. Those are the static ports. They sample the still, ambient air pressure outside the aircraft, undisturbed by the plane's motion. Paired with the pitot tubes, which face into the wind and catch the pressure of the air rushing at the jet, they form the pitot-static system. Nearly every number the pilots trust about their movement through the sky is calculated from the difference between those two pressures. Here's the physics the system leans on. As you climb, the air gets thinner and static pressure drops. Feed that falling pressure into an altimeter and it reads your height above sea level. The airspeed indicator does something cleverer. It compares the ram pressure from the pitot tube against the static pressure from the ports. That difference becomes your airspeed. On the 757, this happens inside an air data computer, an electronic box that reads the ports, does the math, and drives the displays. Every one of those calculations assumes the static ports are open to the outside air. Block them, and the computer is quietly working from a lie it has no way to detect. On the night before the flight, the aircraft, registration November 52 Alpha Whiskey, was being washed and polished. A line mechanic covered the static ports with tape to keep water and polish out of the openings while cleaning the fuselage. That part is normal. Ports do get protected during maintenance. But the covers are supposed to be bright, conspicuous, and flagged so nobody can miss them. Instead, the mechanic used plain masking tape. The ports sit about 15 feet off the ground, and the tape blended almost perfectly into the silver-gray skin of the jet. When the aircraft was released for service, the tape was still in place. Before every flight, a pilot walks around the aircraft on a visual inspection, and checking the static ports is part of that ritual. So how do you miss 3 of them? Height and contrast. The ports sat well above eye level, and plain masking tape against a polished metal skin gives you almost nothing to catch the eye. There was no flag, no streamer, no splash of orange screaming for attention. In the dark, on a routine turnaround, the tape simply vanished into the airplane. This is the quiet danger of the pitot-static system. It has no moving part a pilot can feel and no cockpit light that says the ports are blocked. Flight 603 took off just before 1 in the morning, bound for Santiago, Chile. Almost immediately the trouble started. With the static ports sealed, the air data computers were reading trapped ground pressure instead of the falling pressure of a climb. The altimeters barely moved, insisting the jet was far lower than it truly was. The airspeed indications went haywire, giving the crew conflicting and impossible numbers. The pilots knew something was badly wrong. They declared an emergency and asked to return to Lima. But every instrument they needed to fly the approach was fed by the same poison source, so there was nothing clean left to trust. What followed is hard to listen to on the recordings. The crew wrestled with airspeed and altitude readings that contradicted each other and kept shifting. Because the warning systems draw on that same static pressure, alarms fired on false data, adding noise instead of clarity. Over black ocean with no visual horizon, the pilots had nothing solid to hold on to. They were flying a mechanically sound airplane while their instruments described a completely different flight. Without a trustworthy altitude, they had no reliable way to know how far above the water they actually were, and the sea was much closer than their gauges claimed. The airplane eventually struck the sea, killing all 70 people on board. When investigators from Peru's Civil Aviation Authority recovered wreckage from the ocean, they found the answer still attached to it. A section of the left side of the fuselage came up with all 3 static ports on that side still covered by tape. The seal had never been broken. The aircraft had flown its entire final flight with its pressure sensing blinded, and the cause had survived the impact and the water, stuck to the aluminium exactly where the mechanic had left it the night before. The fix was almost insultingly simple, and that is the point. In 1996, the National Transportation Safety Board issued Safety Recommendation A-96-141, urging that static ports be protected only with covers that are brightly colored and fitted with warning streamers, the kind that hang down and flap in your face during a walkaround. Had Flight 603's ports worn covers like that, a pilot or mechanic circling the jet would have caught them from the ground. Every red remove before flight flag you see dangling from a parked airliner traces back, in part, to nights like this one. The tape cost pennies. Reading pressure correctly is the whole game. And the only thing between them is a cover you cannot miss.